Yeah, so yeah, like I said, this is going to be section 41. So it's recommendation systems. And this is really our last section of module 5. So, after this, we'll go right into the project and introduce that part. So this is kind of like one of our last machine learning algorithms before module 6, which we'll talk about natural language processing, deep learning, neural networks, all that really fun stuff. But it's good to know that sometimes a lot of these algorithms that we've talked about from this module are usually like, sometimes they're deemed as like, sometimes people kind of see them as like, as not as powerful. But in reality is that usually they're a lot easier to implement and a lot, sometimes just as effective. And so one thing is like deep learning is really cool and like really hot right now. But deep learning is not always the best solution. So a lot of these methods that we've learned are actually pretty useful by themselves, even if they're not like the most hottest, newest stuff. Okay, so good to know. All right, so I am going to start sharing my screen once I find my actual screen. I have so many windows open. Why do I have so many windows open? Okay, so again, this section today will be relatively small. Where's my window? Oh, there it is. Okay. No, maybe not. What do you guys see? You see this? Okay. All right. And then I lost you guys for a second. Zoom moved all my windows around for some reason. Okay, here we go. So we'll talk about basically recommendation systems. I actually have this backwards, I think. So we're actually gonna go here. Okay, so recommendation system. So I think, have neither of you guys gone through this section yet, section 41? Okay, that's okay. This is gonna be much more conceptual. So I think this will be good to like introduce you to it. To be quite honest, I think section 41, you can get very lost in the weeds of like the mathematics, like what the heck is going on. So notice that I'm going to be a little more qualitative than quantitative today. Okay, so recommendation systems is basically, let's say you want to actually predict on what someone will like. So the classic of this is like movie recommendations, right? So you think like Netflix. Not too long in the future, there was also like Netflix. I don't know if you guys remember this, or not future, in the past. Wow, I'm really backwards today. But you might have remembered like Netflix would send out like DVDs and stuff like that to people, and like Blockbuster and stuff. So before, it used to be that Blockbuster would essentially just carry the most common video like movies that people would watch. So the thing is, like, they didn't really try hard to like personalize a recommendation. They might say, okay, like, we're just going to put the biggest, movies this past summer, the past few years that we know a lot of people will enjoy, and they know that way it will always get rented out. But those really obscure movies that some people really, really enjoy, other people really don't like care for it. Those weren't really like thought of in Blockbuster or other like movie rentals. So what recommendation system is kind of like what Netflix first did, and it's kind of like the show. I like to show this long tail. And so, has you guys ever heard of the long tail, like in like distributions? Okay, so I see it. I see a little nod. Just to kind of review, is that long tail basically? It's like the idea is that many people have, most people have like a very select, like you can think of like the most common movies, like the things that everyone likes or like likes fine. It's kind of like this beginning part. But as we get to very, very obscure parts, basically less and less people actually like look for it or care for it. And so your goal kind of would be like, let me go ahead and try to recommend the movies that are like maybe very specific to like a certain type of person. So for example, like maybe for me, I really like, watching science videos, and like, very specific, like they go deep into like the science and stuff like that, or a documentary. Like maybe that's something that's very particular to me. There's a movie I'm thinking of, like Particle Fever, which I know like every physics, person I know talks about that documentary, but most people don't ever talk about it. So you can think of that as being like, oh, very specific. So our whole goal would be like, well, if we, this is what Netflix was trying to do and what they're doing now, is saying, well, let's try to find these people who are very specific and try to target those specific people to find their movies. So the reason why you have to do this is because in a lot of ways is that there's just too many choices, right? So like I said, Blockbuster is much more like, let me get the fewest number of movies that will cover most people. And long tail, you're looking at the long tail choices, you can say, all right, let me pick these specific parts. And that's kind of the motivation of like why you'd want recommendation systems. So like we want to recommend things that are specific to that person versus like just the average of everyone. Okay. Now, the thing is that we actually have to like use information to predict this. Well, that's okay since we're data scientists, right? So we're actually going to do this aspect. We're going to use information to predict this. Again, this is probably not really new information about like what we're going to do. So the way we can recommend movies and stuff like this is, how would we think of it in this case that like you're talking to a friend? How would you figure out what your friend, what kind of movie they would like? So what things would you actually do? Like if there's a friend said, what movie should I watch? What kind of information will you, like, how would you base that recommendation?
What they liked in the past, or some general data about like a genre, or like favorite actors, I don't know, like some general information.
Yeah, good. So some information, what movies have you seen in the past, right? What movies have they liked in the past, right? That's an important aspect. What are some other ways we can like maybe judge on what movies to recommend? So like you can say like, for example, let's say they like, you know, I'm trying to think of something like they watched Harry Potter in the past. Well, they likely will like the next Harry Potter movie, right? That seems pretty logical. But let's say we want to find something else, right? Like someone who is let's see here, some new movies that they haven't seen before, but you want to find movies that they would like, but they haven't seen anything like it before. What might you try to do in that case? I'm gonna let you think about that for a little. We'll get to it, but like think of like other ways you would like recommend movies, or like how you would figure out what movies to recommend. So I've put in here like the dumb way, the dumb, quote unquote dumb way, basically like the really like simple way. And I guess of like what you would do. So this is like not considering any person. You just recommend what's the most popular movies right now. So like if everyone's watching the same movie, for example, Minions, like you might recommend the Minions. You might find out that they might not like this. Just because it's super popular doesn't mean something they're gonna like. So this is kind of like the really simplistic way, and this is a lot of ways like I kind of described in like how Blockbuster and other like physical movie rentals, you had to like go and they only carry the most popular items. So like that's essentially what they're doing. They're basically saying, all right, what is the most popular thing? Subscribe it to them. But you know that's probably not the best way, right? So everyone's very unique in the sense of like what data or what describes them and what they should like what kind of movies they would like. So like Ala was saying, there's a few smart ways to do this, right? So one smart way is like content based. So this is what Ala described is basically if you like, you know, Iron Man, maybe you like other Avenger movies, or if you like superhero movies, maybe you like this superhero movie, or, you know, if you like, you know, action adventure, you know, maybe you like these other action adventures. So the idea here is like based on their, what they liked, what movies they liked, you can actually recommend similar movies to them. Makes sense, right? Now, collaborative filtering is a little bit different. So I'm going to kind of put in a little bit scenario. Pretend is that I have this friend, Jim Joe, right? So Jimmy Joe loves these kinds of movies and like likes, I don't know, movies A, B, and C, and D, right? And I have another friend, I don't know, Zach, right? So Zach over here likes the same movies A, B, C, and D, right? So they seem to have similar tastes. Now, if Jimmy Joe watches like movie Z and loves movie Z, okay, it likely means that my other friend, Zach, right, would likely like that movie too, even though they haven't seen it before. Maybe it's not anything like they've seen before, but it's in the sense that these two people are very similar. So in the same way you would say like, oh, if I have two friends who are very similar with each other, like have same personalities, they likely would like the same movie. So if this person likes this movie and this person likes this movie, then I can say, well, okay, maybe if this new movie that this person has never seen, I can recommend it to them. And that's what collaborative filtering is. Okay. So the idea here is like, you know, like, oh, you're just like, you know, like one of my friends, you're just like my brother. I bet you'll like this specific movie. That's essentially what collaborative filtering is. And between those two, that's kind of like the basic idea of like recommendation system. Now we can like quantify it a little bit and it goes in more detail in the curriculum, like what this exactly looks like. But essentially that's the main idea. You either base it on content based, saying like what they've seen before, and then based on what they've seen before, what they enjoyed, you find other movies like that. Or use collaborative filtering when you basically use someone else's experience and say, well, you're very similar to this person, so I'm going to recommend this movie. And what's really nice about collaborative filtering is that it can also encourage movies that this person would have never seen themselves. Like they would have never gone to go watch that movie, but based on other people's interests, it kind of pops up. This is like if you ever see things like a Netflix recommendation or something like that, where a random movie kind of pops up and you're like, oh, that looks really interesting. I'm not really, I don't know about you all, like, but when I like watch movies, I like to watch movies that I know, like shows that I know for sure. But my wife, like, she like uses the Netflix like recommendation system like crazy. She's like, all right, yeah, cool, let me go watch this movie. And it's based on basically one from her content, but also sometimes some really out there stuff where it's like, oh, this is something probably based on someone else and like how they watch these similar movies, so you would like to watch those too. So again, those are the two different ways of recommendation system. Okay. And of course, we have like the really dumb way, essentially, to say whatever's popular. Okay. Any questions on those parts? Pretty straightforward, hopefully, right? Nothing, no strong mathematics involved yet. Okay, we'll get there. So the next one I want to talk about is, let's see here. Did I want to talk about this one first? Yes, I want to talk about this. So neighbor-based or memory-based collaborative filtering. So this is kind of like the really cool stuff, is a sense like you're trying to find that specific person, or you're finding specific people who are similar to, you know, who you're trying to recommend movies to. So this is going to sound really intimidating at first, but it's not that bad. So the intuition here is that if you're you are similar based on how close you are in dimensional space. So the idea here is you're trying to figure out, remember how I said like, oh, I want to find someone who's similar personality? Well, how do I know what that similar personality is? One way we can do this is something like k-nearest neighbors, where if you imagine saying when someone's nearby each other, that means they're similar to each other, okay? So using k-nearest neighbors, we have some similarity metrics. So we can do things like Pearson's correlation, so like that, classically like the little r, right? It's Pearson's correlation. Cosine similarity, basically a similarity between different vectors because there's different spaces. There's also Jacquard similarity, which are basically, this might account more for like, you know, if they actually have ratings for certain like, you know, movies and stuff like this. But the idea here is you have multiple dimensional space and you say, okay, this person's movie habits puts them in this part in like higher dimensional space. And so if you are closer to this person, you likely have similar tastes, so you can recommend the same similar movies. And so that's essentially what this neighbor-based collaborative filtering really is. And these similarity metrics are basically just different ways for us to measure how close to, you know, vectors are. And each vector would represent either a movie or even a person's personality, right? Or person's viewing habits. What kind of moviegoer are they? This is where, like, if you've seen like have you guys ever seen like in Netflix, like how they break down like what kind of movies things are? And they're like I'm just making things up, but like horror, film, you know, teenage drama, like they have like these like subcategories within categories, like this very long thing. Essentially, each one of those categories are kind of like a dimensional space. So like a different direction of like where on the spectrum you would fall. So that's essentially what you would use to make these similarity metrics. Okay. Does that make sense to you guys? Any questions on how similarity metrics or the idea of like being closer in space would relate to like viewing habits or anything like that? Cool. All right. So this is where I say, okay, like that's cool, we can get this part, but how do we actually do this? So one way of doing this is basically something called embeddings. So I think I'm technically sidestepping a little bit because we haven't talked about neural networks or multi-layer perceptrons yet, but this is kind of like how we go through. So basically one thing we can do is use embeddings to create latent properties that best predict the system. So I'm going to read this definition. It takes discrete elements to a dense vector space, which all sounds very technical, but all it basically means is like we say, all right, we're going to take some aspect, summarize it into a vector, right? And then from that vector, we could basically embed information along this vector to help us get an idea of where this movie, let's say we're talking about movies, where this movie falls in higher dimensional space, right, in this vector space. So this is kind of like what this essentially looks like. So if we go back to like our movie scenario, imagine like a movie, like this is like Minions, the movie Minions, is equal to, and this is just a vector, 0.3, comma 0.4, comma minus 0.8. And maybe these numbers represent of like how funny it is, how romantic it is, you know, maybe how much adventure there is, you know, like essentially these are the different metrics. Like in reality, they wouldn't actually be these like how funny, how romantic, or how adventurous, right? That's not literally what it would be, but it gets the idea. So you can imagine, okay, maybe Minions is like 0.3 funny, whatever that number means, 0.4 romantic, and minus 0.8 adventure or something like that. And then what you say, okay, let me get another user. And this user's, we shouldn't say minions, should say like users vector or something like that. But this user's vector might be, okay, like they really like, you know, comedies, they really don't like romance, but they really love action. So like maybe that's kind of like where they sit in this vector space. So this is essentially what you can say, like, well, if these vectors are close together, that means they're probably a good match, or they're similar to each other, which means that they're probably alike to each other since they're close by. Okay, and essentially this is how we would determine what movies are either similar or where a user might actually like this movie or this specific, you know, recommendation. Okay, follow me so far? Sound good? Okay, so does everyone understand like this like vector, like what this kind of represents? Yeah. Okay, so once you understand that these vectors are essentially pointing and saying how funny something is, you know, whatever aspect it is, and then you have another vector, you want to say, okay, how close they are together, right? And you can actually do this with many movies, many users all at the same time. And this actually gets something like matrix factorization. So all we got to do basically is take all the vectors representing all the movie features. So imagine like each row is like a vector, and then that would make a matrix, right? So a matrix of like movies. And then we can say things like vectors representing things like the user features, things that like the user cares about. And you can basically dot product together, and you can see from that dot product what movies would match really well. And basically you would get this vector saying, you know, how if you take this matrix and this matrix multiplied together, you would get essentially this one vector of saying, what's the recommendation for each of these movies? And that can help you decide, you know, saying, okay, well, this one's rated very high on this person's vector, so that means we should recommend this movie, you know, movie A. Or it's like, oh, movie C, it's a very low number, so we won't recommend movie C, and so on. So that's essentially like what recommendation systems can do. This is kind of like the most, I would say like, not the most common, but like it's definitely like a big aspect of how to do recommendations. There are other things I think the curriculum talks about, like social graphs and stuff like that, but I'm also going to focus on it's called like this embeddings, kind of like with latent properties. All right. So any questions on this part of like, you know, how this at least in theory would work? Okay. Thumbs up if it sounds good. Thumbs down if you're like, I don't know. Sideways you're like, don't quite get it. Okay, I see kind of a smile like, sure, I'll give a thumbs up. It's okay if you don't quite understand it, right? So, okay, this is where I would recommend going to this website, kaggle.com, learn embeddings. However, I found out today when I was trying to prep for this lesson, because I really like using this part as part of my lesson, it doesn't exist anymore on Kaggle Learn. So the good thing is, though, I went to the Wayback Machine. Do you guys know the Wayback Machine? For this is fun. So this is the web archive. You can basically search for websites, and if it was archived by someone at some point, you can actually see what the website used to look like. So it's really great to look at things like from the 1990s or something like that. But I had to actually go look for this web part because I was like, oh my gosh, I love this part. It needs to be saved. I think there was one capture back in May. And so basically, this is what the embeddings lesson used to be. And basically it was talking about what we're talking about, recommendation systems, embeddings, and even talks about something called TSNE or TSNE. I just always read it, so I never like say it out loud. But basically, this is a really good lesson. So what's good, I actually found the kernels because they're built on like Kaggle. So I was actually able to like pull them up. But I'm going to show them to you now. Let me go ahead and close this guy. So what this set of like kernel lesson or this lesson did, it walked you through basically how to build these embeddings and then actually, you know, exploring it and seeing how you would do recommendations. So the idea here is that you might have like a list of movies, okay? And then you might also have like a list of like ratings from different people on like, you know, 1 star, 2 star, 3 star, 4 stars on all these different movies and stuff like that. So I'm just going to kind of walk through parts of this. But basically the idea here, and I'm not going to go through this part because we haven't talked about neural networks or embeddings. But basically the idea with embedding here is that we will use something called a neural network, which don't worry about it right now because we'll talk about it in module 6. But essentially we use a neural network to essentially build up these vectors right here. So you see like this vector gets built up. So one way you can build these vectors as well is something like PCA. So PCA using principal component analysis, basically those making super features, and you can imagine these are different numbers on that super feature. Another way we can do it, which is actually pretty cool, is you can use a neural network to basically figure out the most optimal way to put this. And what's cool is that all you have to do is essentially say what this movie is, and then like different features, and then saying, what's it called, what the rating is. And what's cool is that based off of those parts, you can actually build up this latent features, this vector for each one of those movies. And essentially you create this nice vector that you can basically go across it and use that to figure out your different space. So this would be like a more complicated part. If we've talked about neural networks, I could maybe walk through this a little bit more, but we're not going to. We're just going to skip over this part. So the next part then is like, okay, let's say if we want to actually, we have the embeddings, we go through it, we can actually do this vectorization. And I'm trying to see what this is. So let's say, all right, we have what the movies look like the latent features, right? So the embeddings, and then we also have the user part. And what's cool is we can just simply do a dot product between these two, between like the actual movie and like what the user's preference is, right? And we can predict how likely they would enjoy this movie. So if you remember, like if like, let's say this first one's dependent on like action, right? So the movie Twister might have like 1.0 action, like high action, but the user Stanley here has like very, like does not like action, like it doesn't really care for it, right? So this would mean this matchup would not be very good, but maybe there's other aspects within here that if they're matched up really well, they would be a good movie. And essentially here is that this will give us this, this vector dot product with this vector, the movie dot with the user, will give us basically a predicted, like, you know, what's the rating? What do they expect them to like? So maybe you have a cutoff, like, oh, if it's like 4 stars, we recommend it to them. And so that would be kind of like how you would figure this out. So you can imagine, like, again, each one of these, I want to really drive home this point, is that each one of these things represents a dimension, a direction of like how, let's say, actiony it is or how dramatic it is. However, these are not actually like the real values of like, there's not like literally, like, oh, how action is. It's kind of like the embeddings figured out the best way to represent this movies or these movies in this way. So this might actually be a combination of multiple things. But the important part is that it's some combination of like the features that have, you know, latent properties essentially that you didn't give it to begin with. So that's how you would get essentially the star rating. Okay. So what's kind of cool though is that, let's see if I can go to the next part. All right, let's see. Okay, what is really fun is that it's like, let's say we actually go ahead and take the embeddings and say, well, what does it look like in dimensional space? And what's cool is that you can actually plot this out and basically say where the movies are. So remember, similar movies should be close to each other, right? So you can actually visualize this, and I'm trying to find the exact part they talk about this. No, that's not it. Oh, visualizing, that's probably it. Here it is. So here's my visualization. My mouth's going crazy. Okay, so you can see here, you can pretend each blue dot is the movie, right? And essentially, note that we put this down in 2 dimensions. So we use a technique basically to reduce the dimensions. So it should hopefully preserve like the closeness. That way, like things that are close together will still appear close on here. But note that this, if it was a 4D vector, this would be a 4th dimensional space, right? Which we can't visualize, so we just projected it down. But you can see like there's a cluster of movies over here, and you can see maybe there's other movies here. So the idea here is that as we kind of move across this dimensional space, you have movies that are very similar together, and then as you get further away, they're very different from each other. So what's cool about this kernel that's kind of worked through is they've looked at specific parts. So for example, they look at Harry Potter. And so everything that has the word Harry Potter in it, every movie title. And you can see all those green points are all right here. And then they zoom in on here a little bit more, and you can see here, there's, with the labels, Harry Potter, all the different Harry Potters. But then right over here, you can see that's relatively close to it are things like the Hunger Games franchise here. And so this is where you can say like, oh, why is the Hunger Games really close to Harry Potter? And you might start thinking like, oh, like if I were to say, how are they similar? You might kind of think that, you know, they're both kind of teen movies. they're like, more for teenagers, right? Like that kind of group, right? It's for children, but like a little edgier in that sense. They also have, what's it called? It's a series and stuff like that. So you might say like there's some kind of fantasy a little bit in it. Like maybe there's some parts in there that are kind of related. But the idea here is that we didn't have to come up with what metrics describe this movie. Essentially what this embeddings have done is it described the latent properties of these movies and said these movies should be close together. So this is essentially how you can explore this movie space here. So you might find, for example, like this over here is like all these like, very funny, like specific kind of movies that are very similar to each other versus movies over here, maybe they're very sad or very serious or something. So the idea here is that you can find this part. And so if your vector as a user pointed in this direction, right, like right over here, well, then that means you might see similar movies over here. So if you like Harry Potter, you might also like, Hunger Games, or like these are movies that are very similar to each other that are similar to your tastes. Okay. You can see here they go into a little bit further is that they're looking at like the overall structure. And I believe this is just showing documentaries. So you can see all these green points. The documentaries, they're still a little spread out, right? But you can see most of them are kind of close together. So that means documentaries for the most part are a little different from each other, but some of them are a little bit closer to each other. Here it's not really an easy one to show, but you can kind of see the overall color. You can see there's comedy, which is in orange, drama, which is in green, and romance, which is in red. So you can see the green right here is kind of clustered more on this side. So drama's on here. Well, what's the thing that's furthest away from drama? Comedy, right? So you can see the orange right here. You can actually see that separation between different parts. And of course, there's some overlap, or maybe some movies are kind of funny, but also, has some drama in it, stuff like that. And then you can see romance. Romance looks like, I don't know how well you guys can see this, okay, but you can see there's a lot of clustering right here. But you can also see a little bit of red here, a little bit on the drama. So you can see maybe there's some that are kind of like closer to the funny side, like romantic comedies, right? And then there's other ones that are very like serious, dramatic, romantic movies and stuff that are way over here. So already looking at this, you can start seeing the structure of this data set with these latent properties. Again, these like comedy, drama, romance, that's something like a tag that we know, but it's not what we actually put into our machine learning algorithm itself with the embeddings. The embeddings basically came up with these latent properties by themselves, which is I think that's the really cool part. It's like, oh, you don't have to know what's the thing that makes movies different. You essentially say, well, they are different, and based on user ratings, we can put them into different spots, and this will hopefully sort them out into different areas that are really similar. Movies that are really similar will be close together, and movies that are very different will be further apart. Okay, so does that make sense to you guys? How this is kind of gets structured out, at least conceptually? Mm-hmm. Thumbs up sound good? Yeah, cool. So yeah, I would say this is a really great like little notebook to play around with. There's some more, what's it called? Things you can kind of run through this. They're still available on Kaggle. They're just not on kaggle.com/learn. So you have to kind of find them yourself. But if you guys want, I can send you guys the link if you guys want to explore this. What's really kind of cool about this, because they're vectors, is you can do some interesting like math with like the semantics. So for example, if you say like the movie Scream, so I don't know if you guys have seen the movie Scream or know of it, right? But we have the movie Scream and then Psycho. So we can say what plus Psycho is equal to Scream, because these are just vectors. We can add them together, right? And so we can say like, well, okay, this person, when they go through it, actually says like, okay, like, well, what would this movie be? Like, how are these similar with each other? Well, Scream and Psycho are both kind of like thriller, kind of movies, right? But Scream definitely has a different feel than Psycho. Scream's a little more lighthearted at parts. And so it turns out if you actually find what are the things, that are missing from Scream, what's this difference between the two, you can see a few things like Scream 3, Scream 2, like, okay. But you can start seeing Piranha, which is, I don't know if I've seen kind of this part, it's kind of campy, where it's kind of like, a little not serious in that way. You can see Booty Call, Charles Angels, Mortal Kombat, Deuce Bigelow, Male Gigolo. So you can start seeing like there's some kind of like bit of funniness right here. And what's missing here, and the kind of reasons, Scream is a comedy. And so it's basically saying the difference between these two is that there's some extra comedy within Scream that's different from Psycho. So that's kind of like saying, that's the parts that are missing from this movie. So you can do some interesting semantics. So this right here by itself, like movie recommendations, wouldn't be necessarily useful, but this will actually just really well into like NLP, when you look at like different words and stuff like that, you might actually look for things that are similar to each other, and you can use something like embeddings, or in this case, it would be like word embeddings to actually pull this information out and see how they're related together. Okay. So anyway, I thought this was a really interesting way of approaching like how different movies are from each other. And I think it helps also drive home the idea that these movies' locations, which are just vectors, right, will actually keep some of these properties of how they relate to each other and how they're different from each other. Cool. So yeah, that kind of ends everything that I want to talk about for recommendation systems. Do you guys have any questions? No? Okay. Well, let's stop recording here.